Okay, you're welcome. I know some of you don't understand the chemical properties of acid. So I have to do this again so that at least to give you, you know, uh, more explanation about the chemical properties of acid. So very quickly, let us talk about chemical properties of acid. You see, we are talking about reactivities of acid. Are we together now? We're talking about reactivities of acid. Now, what's the first thing we need to talk about? Remember, we said number one, we said acid will react with metals. Acid will react with metals. That's the first thing you need to know. Acid will react with metal. But the question is, which type of metals? Are you getting me now? Which type of metal are we talking about? We're talking about strong electropositive metals. Strong electropositive metals. I hope you're following me. And this invariably, we're talking about the what? Alkali metals and alkaline earth metals. So invariably we're talking about group 1 and group 2 metals. Are we together now? Talking about group 1 and group 2 metals. So these are the things you need to know first. Acids will react with metals. And the metals we are talking about are strong electropositive metals, which are the group 1 and the group 2 metals. Now the question is, when acid reacts with metals, what will happen? So when acid plus metals will give us salt plus hydrogen gas. You get it now? I hope you're following what I'm saying. Acid reacting with metals will give us salt and hydrogen gas. So let's take, for instance, our acid. Let's take hydrochloric acid, HCl, reacting with zinc. Zinc is a metal, abi? So it's going to give us zinc chloride plus hydrogen gas. So let's balance it. Chloride is 2, hydrogen is 2, so we put 2 here. Exactly now. So let's take another example. Let us take another example. H2, our sulfuric acid reacting with magnesium. With magnesium is going to give us Mg what? MgSO4. MgSO4 plus what? Hydrogen gas. Is that clear now? Is that clear? That's what we have been talking about. Sorry, don't mind my class. So when acid reacts with metals, it's going to give us salt and hydrogen gas. This is salt, a chloride salt. This is sulfate salt plus hydrogen gas. Are we clear now? Yes, we are clear. Okay. Can I get my duster? Okay. So now let us now go deep a little bit and look at the exception. Please go and bring me that duster. Okay. So now let's look at some exception. You see, we have used HCl, we have used H2SO4. Now we said, with the exception of what? We said, except if you use dilute what? When you use dilute HNO3, nitric acid. When you use dilute HNO3 with the nitric acid, we said it is not going to liberate hydrogen gas. So will not liberate hydrogen gas. Is that clear now? Is that clear? Please help me with the duster. So when you use diluted HNO3, it will not liberate hydrogen gas. Are you getting me now? And the only reason why it will not liberate the only reason why it will not liberate hydrogen gas is because whether it is dilute or concentrated, note that whether it is dilute or it is concentrated, it is what? HNO3 is the what? Is a strong oxidizing agent. Is a strong oxidizing agent, and what will happen is that it will oxidize. You get now, when you use diluted HNO3, the reason why it will not liberate hydrogen gas is because it will oxidize what? It will oxidize the hydrogen gas to water, and in the process of doing that, it will get itself reduced to what? Reduced to any of the nitrogen oxide. Are we clear now? It will get itself reduced to any of the nitrogen oxide. I hope we're clear now. So let us take, for instance, you take copper, you react it with HNO3. Your expectation is what? You are expecting to get salt and water. No, you will get salt, copper, plus nitrogen oxide. Nitrogen oxide plus what? Plus water. Is that clear now? So we balance this now. We balance this, you see that we have what? 1, 2, 3. This is 6, 2, that's 8, 9. You get it now? And this is 2. Nitrogen 2, 2. So it is not nitrogen 2 here plus 1 here. So it is better to put 4 here. So if you have 4 here now, you have 4 here, 2 here, I think it's balanced like that. Let's check it. Okay, 4. This one is 4. Okay, 2 here also. 2 here. 4, 4, 4, 2, 2. That's 4. So you can see now. So the hydrogen gas that we're expecting has been what? Has been oxidized to what? To water. And as such, the nitric acid has been reduced to what? Has been reduced to nitrogen oxide. Is that clear now? Is that clear? So what we're saying invariably, you have to take note that acid will react with metal to give us salt and water, but when you use dilute HNO3, it will not give us I say salt and water. When you react acid with metals, it will give us salt and hydrogen gas. But when you use HNO3, it will not give us what? It will not give us the salt and the hydrogen gas, but rather the hydrogen gas that is expected to be liberated. Are you getting me now? The hydrogen gas that we're expecting will be oxidized to what? To water. Now, but the question, let me shock you a little bit. You see, it is not that nitric acid does not react with metals. No, that's not what we're saying. We're not saying that it does not react with metals. No. It will react with metal. Only that hydrogen gas will not be liberated. Now, let me now tell you that we have 2 elements that can react with nitric acid that will actually produce hydrogen gas. That is now. So we've seen that. So let us now look at this that will now produce hydrogen gas. So magnesium and manganese. Magnesium and manganese will liberate hydrogen gas when it reacts with HNO3. Is that clear now? So when you take Mg plus HNO3, it will liberate Mg NO32 plus hydrogen gas. You get it now? So we balance this, okay? 2, balance. I think it's balanced like that. So the same thing happened to manganese. When you use manganese, it will give you the same thing. Can you see that? Yeah. So magnesium and manganese, when they react with nitric acid, when magnesium and manganese react with nitric acid, it will liberate hydrogen gas. Take note of that also. Take note of that, that we said that nitric acid will react with metal, but instead of liberating hydrogen gas, it will liberate water. It will oxidize the hydrogen gas to water. But we are say that we still have two elements that will react with nitric acid and at the same time give us what? Hydrogen gas. And the reason for that is because magnesium and manganese are what? Are strong reducing agents. Note that magnesium and manganese are strong reducing agents. So what happens is that they reduce that water. They reduce water to hydrogen gas. So instead of nitric acid giving us water, you remember, instead of nitric acid oxidizing the hydrogen gas to water, you get it now. The magnesium and manganese will reduce the water to hydrogen gas. Hence, manganese and magnesium and manganese will definitely liberate hydrogen gas. I think we are good on that. So if you are good on that, we can actually proceed with the other aspect. So that is that about the chemical property number 1 of acid, which is acid reacting with metal. So number two is that acid will react with base. Acid will react with base. You get it now? This reaction is referred to as neutralization reaction. So it's neutralization reaction. So when acid react with base, it will definitely give us salt plus water. Take note. To give us what? Salt plus water. Are we clear now? So let's take acid. HCl reacting with base NaOH will give us what? NaCl, sodium chloride, and water. You get that now? That's what we are saying. Is that clear now? Thank you very much. And the last part of it, I hope we are clear with this one now. Acid will react with base. You understand me now? Acid will react with base, and the reaction is called neutralization reaction. When it reacts with base, it will produce salt and water. Are we clear on that also? We are clear on that also? Well, then we'll move on. So number three is acid. Can I take a new chalk? Let me take new chalk. Thank you very much. So acid acid will react with carbonates. We react with carbonates. You remember Na2CO3. You remember example K2CO3. You remember CuCO3. These are some of the examples of carbonates. So when acid, that is one thing you have to know. When you take your acid, look at it. Let us take. When you take your acid H2SO4, for instance, reacting with let us say CuCO3. Let us use CuCO3. It's going to give us CuSO4 plus water, H2O. Then there will be liberation of CO2. Are you clear now? There will be liberation of CO2. I think it's balanced. Yeah. So you can actually do this by yourself. Take any of the acid. You can use HCl with all this. Are you getting that? So the last part of it that I want you to understand is this. Now, look at this. CO2 will be evolved. The gas will be released. Are you getting me now? So the gas that is coming out, how do you know that it is CO2? Yes? So for instance, let us say this is my reaction tube. Yes? So if I want to confirm which gas is this, you can see this. So I use my cork. I use my cork like this. So down here I have my carbonate, and here I have my dilute acid. So here, inside here, I have my lime water. So I will allow the gas to come in contact with the lime water. So if that gas is CO2, that is it, I'm testing for gas now. I'm testing whether the gas is CO2. So if the gas is CO2, definitely that lime water will turn milky. Guess now, that lime water will turn milky, which is an indication or confirmation that the gas that is being released is CO2. Because it is only CO2 that will react with lime water and convert lime water to milky. Are you getting me now? So CO2 will turn lime water milky. Do you get it now? So which is an evidence that the gas that is being released when acid reacts with carbonate is COO2. CO2. Are we clear now? So if there's any question, please always feel free to give me your private comment. That is the end of chemical properties of acid. So if there's any other question, again, drop your private comments. Thank you once again. I am very sure that at this point you should not have any problem with chemical properties of acid. Number one, to react with metals. And when it reacts with metals, it will give us salt and hydrogen gas. I said when you use dilute HNO3, it will not liberate hydrogen gas. Rather, it will oxidize the hydrogen gas to water. And in the process of oxidizing the hydrogen gas to water, it will get itself reduced to any of the nitrogen oxide. I said, however, there are still exceptions. We have magnesium and manganese, which are strong reducing agents that when they react with what? When they react with nitric acid, they will liberate hydrogen gas. Why? Because magnesium and manganese are strong reducing agents. And number two, we said acid will react with base in a neutralization reaction to give us salt and water. And the last one, we said acid will react with carbonates. And when it reacts with carbonates, it will give us salt, water, and carbon dioxide. And to confirm that the gas that is coming out is actually carbon dioxide, you use lime water. And if it's CO2 truly, it will definitely turn milky. Thank you very much. Peace out.